So we're going to be doing a practice problem for one of the practice midterms that are posted. This is going to be problem number 1, question 5, where you're given 2 reagents, 2 starting materials, and you have to determine what the product is. So hopefully by now you can realize, based off of the reagents and with their starting material, that this is going to be an aldol condensation. Remember, your aldol condensation is either going to be a combination of a ketone and an aldehyde, or 2 ketones and 2 aldehydes, or 2 aldehydes. In this case, we're dealing with 1 aldehyde and 1 ketone, so fits the qualifications for aldol condensation. So the first thing is to figure out which one of these carbonyl compounds is going to be our nucleophile and which one is going to be our electrophile. The requirement to be a nucleophile, again, is to have an alpha hydrogen present. So if a base were to come in and take off that hydrogen, you would result in an enolate, which would be able to react with an electrophile. So the compound on our left, we can see that there's no alpha hydrogens present. On the right, it's connected directly to a hydrogen. And on the left, it's connected to a benzene ring, in which both cases we don't have any alpha hydrogens. In the case of our ketone, we can see there are 2 alpha hydrogens on both sides. Because this molecule is symmetrical, both of these hydrogens are equivalent, so it doesn't really matter which one we use. And so this ketone is going to be our nucleophile, and then this aldehyde is going to be our electrophile. Again, that is because the electrophile doesn't have any alpha hydrogens. In this case, it's a benzene on one end and a hydrogen on the other. And a nucleophile has alpha hydrogens on both sides. And because the molecule is symmetrical, it doesn't really matter which one we choose. So start off with our base. Our base is given as a hydroxide ion. It's going to come in and pick up a hydrogen. The electrons between that carbon and the hydrogen will drop in between the carbonyl carbon and the alpha carbon. And then the electrons between our carbonyl carbon and the oxygen will end up on the oxygen. And so what we end up with is an enolate. Which is ready to act as our nucleophile. So now we have our nucleophile ready for attack. The electrons on O will drop down to reform a carbonyl, and these electrons will go in and hit our partial positive carbon of the carbonyl, pushing these electrons onto the oxygen. And so what we end up with is our ketone. Our ketone is attached to the carbonyl carbon, which is going to be the pink dot. That carbonyl carbon is attached to an O-, a hydrogen, as well as a benzene ring. If you get confused in which substituents are where, I highly recommend either using a dot to indicate which one is the carbonyl carbon of the electrophile, or to number out the carbons on the electrophile to make sure that you're getting all the substituents in there. Our second step of the aldol reaction is to protonate our O-. Remember, there are no good leaving groups in our aldol condensation. So instead of the electrons on oxygen dropping down and letting a leaving group leave, the oxygen picks up a proton, and we result in a neutral species which is our beta hydroxy carbonyl. Okay. Since there's heat in our reaction, that tells it it's an aldol condensation and not just an aldol reaction. And so the heat is going to provide the energy to kick off the OH and remove a hydrogen off the alpha position. And so a base, again in this case we'll use OH- again, will come and remove that alpha hydrogen. The electrons between the alpha hydrogen will end up between the alpha and beta position, and then the OH leaves as OH-. And so our final product is going to be an alpha beta unsaturated, as expected, and we'll have OH- in solution. So going back, our nucleophile is the one that's going to be having alpha hydrogens present on it. Our aldehyde is going to be the electrophile. The base will deprotonate off the alpha position, resulting in this enolate structure. the enolate will act as an electrophile and will hit the act as a nucleophile and hit the electrophile, resulting in an intermediate where you have a negative charge on the oxygen. And because there are no good leaving groups, you're going to end up with a beta hydroxy group, carbonyl, as the oxygen picks up a proton. And with the help of heat, will result in a alpha beta unsaturated compound as your final product.